Now I'd like to introduce Dr. Tom Winston, Dragos's Director of Intelligence. Hi, Tom.
Hi, Megan. Thank you very much. Good afternoon, everybody. Just wanted to spend some time with you today talking to you about a risk assessment technique that I stumbled upon this past summer. Frequently when I'm hit with these ransomware requests or requests for information about ransomware compromising manufacturing or other industrial entities, I'm always thinking of ways to sort of better approach this problem set. And there are many ways. We know traditional methods like defense in depth are somewhat useful, definitely, but there's no one thing I would say before I get into the main presentation. There's no surefire way to protect against all threats. That's the main takeaway. And as I was thinking about this, I was thinking back to my political science studies and career, where we were always trying to quantify things that are typically qualified in discussion. So that's where this all sort of came from. I put this paper together last summer at the beginning. So the things we're going to talk about today, just some ransomware trends and their impact on ICS. Definitely, we've seen that this year. There's going to be a few recognizable things I'll be sharing. Emergence and disappearance of ransomware adversaries. This is an ongoing story, certainly not written completely yet. I think we're going to see a continuation of this as well in the future. A risk assessment metric to prevent ransomware. And again, this is not a solve-all solution, but it's just a way to sort of consider assessing your risk overall in your organization, actually based on some classic math and complex systems theory. So we'll talk through all that. I hope I make it easy and fun. You may see some terms in there that you'll remember from maybe your far past or maybe your short past. But to kick this off, we'll just talk a little bit about how with connectivity. Connectivity is really the issue that's causing these problems. The pandemic certainly exacerbated remote connectivity issues, because industrial organizations needed to find ways to quickly get their workers in work from home arrangements to access critical functions in the factories or plants. So with increased investment in digital transformation and hyperconnectivity in manufacturing, of course, we actually develop a lot more vulnerability exposure. And findings from a Trend Micro report showed that 61% of manufacturers had experienced cybersecurity incidents in their smart factories, with 75% suffering systems outages as a result. 43% of those lasted more than 4 days. Few, if any, plants are truly air-gapped. And there's a whole area of research actually separate from this conversation about air-gapping and what that means and what it doesn't mean. And the second trend is a growing threat landscape and greater exposure to cyber threats made possible by that same connectedness that provides the benefits of digital transformation. So it's not just a pandemic exacerbation, it's really digital transformation that's changing the connectivity between, not just inside the plants, between enterprise IT and operational technology enclaves, but also remotely from workers' homes to monitor and maintain those things. Just a quick look at ransomware by country. It's obviously not just a problem in the United States, although the United States has 32% of the incidents. We can see that this problem is actually distributed fairly well worldwide, especially in areas where there's more industry and technology connected. And you can see that it's pretty well distributed. Really, a lot of the numbers are in the 1% to 3% range. But of course, with the US being at 32%. If we look at ransomware, by ICS vertical, and this is obviously something that Dragos considers very carefully as well. We see that manufacturing, of course, which encompasses many different things, has 58% of the ransomware incidents, ransomware events, if we want to call them that. And we can see that some of the other areas that have it are chemical, food and beverage, ICS equipment distributors, energy distribution, transportation. energy, not just distribution, but also all aspects of the energy sector. Now, this slide actually is looking at the ransomware attacks per manufacturing. And this is just breaking down that large chunk we saw on the last slide. And you can see that biotech, food and beverage, drilling, aerospace, et cetera, are among those areas that have experienced ransomware or some sort of incursion from ransomware. And typically, again, it's not that organizations aren't aware that ransomware is a risk. It's absolutely 100% true that organizations, especially today, are aware. And this is not the first year we've seen a lot of ransomware in ICS verticals. So they're definitely aware. It's more of a matter of how do we sort of formulate a risk assessment that properly addresses all of the issues that organizations face between enterprise IT systems, connectivity to operational technology systems. And again, there is no one solution fits all. A couple of the things I was going to discuss with you, JBS Foods experienced in late May this past year. It's the largest meat processing company in the world. They experienced a pretty disruptive ransomware attack. They discovered chunks of data uploaded to the mega file sharing service. The uploads continued sporadically. 40 to 60 gigabytes of data were uploaded. And again, a lot of what's happening with ransomware is there's really two things we have to consider here. There's the threat to leak the information to the data leak sites, and that information can range from organizations your organization does business with, to personally identifiable information, to contracts your organization has signed. So there's that aspect of it, but then there's also the more sort of impactful to daily operations aspect of it that encrypts file systems. And in situations where we see or enterprise IT connecting directly to operational technology via SCADA software or something like that, we especially have a risk because those enterprise IT machine systems may have more exposure than some of the stuff back in the OT section of the organization. So this may have been the work of a JBS employee, but Dragos assessed with high confidence the activity can be attributed to ransomware actors, as Mega has been used to store information by other ransomware actors in the past, and 3 other exfiltration campaigns. So Dragos assessed with moderate confidence that ransomware groups will continue slow exfiltration of data, possibly to avoid activating security controls in the months and weeks leading up to a ransomware extortion event. And we actually saw another one of these with an organization in the Midwest, where large manufacturing organization, and this particular organization, we heard there was a ransomware attack, but we couldn't verify it. But then about 3 weeks after we had sort of heard the initial buzzing about this potential attack, there was data leaked to a data leak site, and that was sort of confirmation that there was in fact an attack on that organization. So we do see things like this quite a bit. And of course, we have Colonial Pipeline. I think this one sort of goes without saying. People, anybody who lives in the parts of the United States where you see this pipeline, which is a large swath, actually a very large population in these areas of the United States, knows that when that occurred, there was quite a bit of disruption. Actually, there was panic too. I would say as much panic as there was disruption to get to the gas station. I think I can recall driving at 12 or 1 in the morning because I knew something was coming, and then there was quite a bit of disruption. And this was dark side ransomware attack that impacted the computerized equipment managing the pipeline. And the gravity of potential attacks on these type of critical infrastructures, has always been a concern. It's certainly something the government has been addressing, organizations have been addressing for many years. But this one hit hard. As the largest fuel pipeline in the US at the time of the attack, Colonial Pipeline delivered approximately 45% of the gasoline consumed on the East Coast. To contain the attack, Colonial Pipeline decided to halt its operations, and the shutdown created some shortages at the pump, as well as panic buying. So with Colonial Pipeline's billing system compromised, the decision to shut down The entire pipeline was made in order to isolate and contain the attack and to help ensure the malware did not spread into the operational technology network controlling pipeline operations. And that was according to the CEO of Colonial Pipeline, Mr. Joseph Blount Jr. And basically, the pipeline did pay $5 million in Bitcoin ransom the next day for a decryption tool that was so slow that Colonial used its own backups to bring the system back online. And that's another point, actually, about ransomware that so we have three things that happen with ransomware. We have the encryption of the file systems. We have the personally identifiable information or corporate confidential or sensitive information being leaked to data leak sites. And then we have the decryption tools that these ransomware actors supposedly sell. You're paying for that tool that may or may not actually work 100%. So there's those three areas create just a greater risk than normal attack vectors, because it's really three different things. So about that, ransomware groups coming and going. Law enforcement, federal law enforcement in this country and other countries around the world is aware of the group's activities, and they do spend some substantial time investigating, tracking, following. But as a person who personally tracked organizations who are committing cyber crimes in the past, I know that this can be very difficult because the people move, they switch countries, they can switch their tactics, techniques, and procedures, and they can, in many instances, appear as something else or somebody else with no warning to the victims, unfortunately. So the this REvil ransomware group has reported they were reportedly dealt a severe blow, and this is late October, courtesy of an operation conducted by officials in the U.S. and other countries. Interpol was involved, FBI. Law enforcement, intelligence, cyber specialists hacked into REvil's computer network infrastructure, thereby taking control of at least some of the group's servers, according to information from 3 private sector cyber experts working with the U.S. as well as one former official. So what will happen is the groups they'll pop up, they'll conduct an attack or 2 or 3 or 20, and then they'll disappear, and then they'll reform. They may even rebrand themselves or come up with a new name. But typically what we'll see in that case is similar tactics, techniques, and procedures used, which leads intelligence analysts to sort of discern whether it's, Conti, whether it's REvil, whether whoever. So Dark Side is another one that hit quite a few organizations this past spring. So in some instances, and this is always a concern, we don't really do too much attribution at Dragos per se, but occasionally, actually more than occasionally, fairly regularly, we'll hear a government organization claim that one of these ransomware organizations is state-sponsored. And if they are, they're well-funded. They can be very well-funded. They're going to have the ability to move, change, and adapt quickly to changing law enforcement pressure, whatever. So, and this is something that we've seen a couple times this year, and we saw it a couple times in 2020 as well, in 2019 too. So they disappear, they come back, and then let me get back to where I want to be. Okay. Ransomware risk assessments. All right, so now we talk about risk assessment. This is a really complicated area, and there's a whole bunch of different risk assessments. There's sort of the classical risk assessment approaches that organizations will use. We can talk about defense in depth, and we can talk about securing computer systems against intruders, and we can talk about how defense in depth sort of relies upon a multitude of layering, devices and practices that allow organizations to minimize risk, but never really remove it totally. So some of the ransomware, as I mentioned before, has been preying upon work from home arrangements, weak access controls through IT, OT integrated systems. And we saw a couple of these instances this past year. There was the Oldsmar, Florida water contamination instance, which was caused by somebody accessing the chemical solution system remotely and creating an instantaneous problem that was fortunately caught by actually OT operators on site. So when I think about things like this, I wanted to think about a way to quantify some of these risks that typically mechanisms like the Purdue model or defense in depth attempt to qualify. So by quantifying this and saying, here's your risk assessment, here's a number, it could be an interesting way. And again, it could be an interesting way to sort of say, wow, we're really exposed in access control, or wow, we're really exposed in our enterprise IT security, or there's a whole bunch of things that could come from the risk assessment. And this risk assessment tool looks at each of the several organizational security functions using qualitative mechanisms. So people would sit around in a room with a whiteboard and they'd say, okay, we've addressed, these 7 problems. We think we've addressed them fully. And then we have these 12 problems over here that we may have addressed half of, the potential issues. So each of the functional risks are then multiplied to get an overall risk exposure to malware. Okay, my mouse has a mind of its own here. Rooted in complex systems analysis and differential calculus, but easy to use and implement. And again, I don't expect anybody to actually look up the underpinnings of the math that I used here to describe this. I think it's very interesting from a systems engineering standpoint, but beyond that, I was very free to sort of look at this way of optimizing systems. This is a systems optimization formula, actually, and consider each system of systems. In other words, you have your enterprise IT system, but within the enterprise IT system, you have the networking components and devices. You have protocols that you use to communicate, obviously TCP/IP being the primary one. And then you have, you have operating systems interacting with each other, Unix operating systems, Windows operating systems, and that's an enterprise IT. OT, of course, you have different protocols, proprietary protocols like DMP3 and things like that, Modbus, those things communicating between devices in that section of the network. And most of that, of course, can be ported over TCP/IP. So we look at these things as there's the devices within the systems, and then we have the way the devices are connected within the systems, and then we have how the systems interact with each other. So this is how this is where I came up with this risk assessment. Let's look at the function of security. That's F of capital S equals the small security function of IT times the small security function of OT times the small security of access control times the small security function of auditing, AU. And again, auditing, a lot of people think auditing isn't really, it's less exciting. When we talk about cybersecurity, we talk about even in OT environments, it may not be as exciting. But auditing is actually a really good way to, looking at log files and things like that. It's a really good way to figure out when things started and maybe even how they started. So there's a lot of use here, certainly in auditing, and it doesn't require the level of knowledge you need to do things like reverse engineering and things like that. So it's actually something that's very accessible. I think auditing is a very accessible security function. And that's what I said, the compromise, that we comprise the function of security, big S, as the function of security. So it's this. So we're basically going to look at each one of these systems and point to various. There can be any number of variables in that system actually too. It's user defined. It's organization defined. So how did I come up with this? Well, I was reading. I know this may sound strange, but I was reading on a warm summer day this past June a paper about optimal control theory, because I'm always thinking of ways to take really complicated topics like optimal control theory and the Hamilton-Jacobi-Bellman equation. Those are actually fairly complicated concepts in systems theory. But as somebody who was a former professor of cybersecurity engineering, I always look for ways to take something like this and make it more accessible to everybody, because there's some really interesting things in math that I think have great application to, any cybersecurity conversation. Certainly, people planning budgets for their organizations can appreciate how much math helps, their annual planning. It's always easier to say, here's how we came up with this number. So I was thinking about this, and it is, in general, a nonlinear partial differential equation in the value function, which means its solution actually is the value function itself. Of course, in differential equations, we typically solve problems and use many times our solutions are actually other equations which isn't really the point here. The point actually is that the loss function recognized in ICS environments, loss of security, we'll say, is not only affected by the IT environment, but by the product of the functions of the whole of all the systems, both enterprise IT and operational technology interconnected. So again, let's look at the systems separately, because like the Purdue model will show us a nice layering of here's your enterprise IT, and then at the very bottom you have your devices controlling processes in the OT environment. But what we're sort of missing is, how do these systems interact? How do they look at, how do they communicate with each other, and what can go wrong? That's obviously my concern now, is where can this break down? So the value function here can be the cost benefit analysis of the decision calculus. And all that means is people sitting around in a boardroom or in a lounge or in any sort of room at a restaurant discussing their security implementations. What have they done? How do they make the decisions to secure their environment? What policies have been drafted for access control or multi-factor authentication and access control environments? How do we protect ourselves from risk outside? How do we protect ourselves from ransomware, really? So, and that's how I view the value function. And the analogy here to the Hamilton-Jacobi-Bellman equation fits, because in mathematics, the HJB equation is usually solved backward in time, starting from T, meaning today. So T, lowercase t equals capital T, meaning right now, and ending at T equals 0. T equals 0 is interesting here because typically the ransomware attacks that Dragos has investigated and other organizations have been investigating around the world happened before they were discovered. So there wasn't something that was triggered necessarily in an intrusion detection or intrusion protection system that said, hey, you're being ransomed right now. You're being something bad is happening. So we want to look at that time. That actually matters in many instances, because sometimes the time it takes to discover sort of the compromise can be relevant to how far the systems have been compromised. So practically speaking, this refers to the time between the actual ransomware compromise and the time discovered. And there's anecdotal evidence that shows that ransomware adversaries take careful steps in time to gain a foothold and move laterally across systems. And of course, time is differentiable in terms of the degree of infection or the success of the ransom. So my formula, I'm now going to explain to you the 4 components that I use here. And again, technically speaking, you could have more than 4 components here. You could add something to this. You could say operating system security, for instance. You could set up a whole risk calculus. So this formula, you can modify this and adjust this to your needs, to your flavor of your organization. So the security of IT is the sum of actions taken in this category: up-to-date patching, vulnerability management, all connected components. Each component in the IT infrastructure will have its own set of security controls. Some of these may include database security controls, like if they have a data historian that's forward-facing, for instance, web server security controls, host-based operating system security controls, network security controls, et cetera. So that's really defense in depth, right? And then security of OT, the sum of actions taken in this category: up-to-date patching and vulnerability, hardware and software, all devices comprising the OT infrastructure, secured protocols, segmentation between functional or protocol-based boundaries. And again, these are just variables here, folks. You can add as many variables as you want to this, or you can take variables away. And the other 2, access control, we look at access control is a big deal now. I mean, it's always been a big deal, but it's a bigger deal now for work from home arrangements. And obviously organizations benefit greatly from work from home arrangements where, an OT engineer is able to monitor his or her processes from a remote environment. I think that actually helps secure the organization overall if there's some attention paid to access control. So again, this is just a listing of some of the variables you can have: secure remote access paradigms, multi-factor authentication, things like that. And finally, of course, we have auditing. Auditing IT logs can help prevent ransomware, with the obvious exception of the case where ransomware adversaries use new 0 days, which we won't find out about until they happen. And anomalies caused by initial access vectors can usually be detected somewhere early in the ransomware cycle. So, and a lot of organizations invest time, effort, and training into intrusion detection. Ransomware adversaries, they use blended approaches that affect simultaneously different parts of IT infrastructure. So it's not just the logs, but database logs, firewall logs, maybe net flow monitoring to and from your ingress and egress points, all kinds of useful approaches here. And again, you can change or modify these variables as you see fit in this particular form. So what ends up happening is you take that security, we'll say IT here, security of IT, and you just take all of those variables and you add them together, and you take that sum and you divide it by the number of variables you used. So each variable represents a measure taken to improve the organization's cyber defense posture. There can be any number of such measures, and a measure can mean a patch, a configuration, a detection, any method taken to secure infrastructure. So you can have 20 of these, you can have 6 of them, you can have 5,000 of them. It's really up to you. So remember, closer to 1 means more prepared. So I built this out so that 0 is not prepared and 1 is prepared. So in this organization, we have a group that's not prepared for ransomware, and we see that we have the 4 values here. Their security of IT actually looks pretty good. Their IT department's on top of their game. They're doing a great job. Security of OT, not so much, and security of access control, not so much. And their auditing is missing. It's miserable. So they scored a 0.07 there. So what F of S ends up being is 0.02. The product of the composed functions is really bad. This is very obvious. If you look at this, you'd say, wow, this is terrible. We gotta work on this a little bit. So, and again, I just used 6 security measures here, and this is, again, you can test this and work it as you see fit for your organization. So here's what one of the security measures looked like. We had 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.005. And again, arbitrary. You can decide as a group what you think we have one firewall, it's 10 years old, we haven't updated and patched it. I would give that maybe a 0.005. Again, this is all qualifiable by your staffs, your organizations who are running security. And the important thing to note about this is that it might be representative of what will be found in a lot of organizations. And again, it's not because organizations aren't trying to do their best. I would never, ever say that or propose that. Organizations are trying to do their best. It's just that unless you're sitting down and you're thinking about the constant interactions between the systems of systems, you may miss something. So this is a simulated, not prepared environment. Whoops, let's go back. Again, here's a prepared organization. We see that their function composition comes up to 0.961. That's really good. I doubt too many organizations are like this. Maybe if you're unplugging yourself from the internet every night. Again, these are arbitrary numbers. The steady state here, 0.961. The steady state here would be a straight continuous line at 0.961. Any perturbation, in other words, breach, pwnage, maybe you forgot to patch something, it's going to cause that line to drop. So if you're thinking of this in terms of horizontal and vertical, this would be a straight horizontal line at 0.961, and perturbations would cause that line to drop or fall off a little bit. So basically, this is a very, very sort of simple and easy to implement approach to look at risk in any environment. And because ransomware poses a special problem, I decided to focus this risk assessment on looking specifically at ransomware issues that occur. Now, there's obviously more work to be done here. I would never, ever say that this is complete and it's wrapped up and finished. I think that there are many, many modifications that can be made to this formula to make it more efficient for any organization. And these are the sorts of things that I actually stay up late a lot of times thinking about in the wee hours of the morning, because it's always been curious to me, how do we quantify things that are typically qualified? And again, qualifications would be like, we have a multi-factor authentication policy in place. That's something that's qualified, it's written, but you can assess that with a value using this risk assessment formula. And of course, on the last slide, I just look at summary recommendations. And really, they kind of refer to the 4 areas we're looking at: visibility, third parties. Look at the connections of third-party connections you're using. Make sure that those OT interactions are monitored and logged. If you're storing stuff in a data historian, which a lot of organizations will, make sure that the data historian is secure from the enterprise IT environment. That's kind of a roadmap to all of your process functioning. So that's obviously something that would be very relevant. Access restrictions and account management, we can talk about that too. And everybody, you hear the story about passwords all the time and things like that. Nothing new there. Response plans really relates to auditing. Let's keep an eye on what's happening in our environment so that we can respond to things quickly and efficiently. And visibility, of course, is always very useful in operational technology environments, knowing what you have, where it is, what its status is, software and or hardware status, whether it's been patched. And I do understand that patching hardware in OT environments can be very difficult. Maybe downtime's not allowable, maybe downtime's not really permitted. So these things are challenges. I totally respect and recognize that. With that, we can do some questions here. I want to thank you all for your time.
And Tom, we have some questions in the Q&A chat, if you want to tackle some of those.
Okay. Okay, starting at the top, 32% seems to be an insane amount compared to the rest of the world. So this data was taken in a 2-month period over the summer. So it's possible, Lucas, it's very possible that we have some data collection bias. Maybe we were focusing more on North America. It's actually very possible that that's the case. So I think sometimes seeing the stuff is one piece of it, but actually understanding why the stuff is there is another piece entirely. So no, that's a fair question. Okay, Brian Hammond says, are there no malwares? Great question, Brian. We do have some small difficulties getting information about ransomware or malware incidents from Russia and China for obvious reasons. There is an embargo typically on information coming from those countries that we're able to get. And unnecessary poking and prodding in those countries could lead to some bad results. So yes, we definitely have blind spots. There's no question. I think every organization in the world, to some degree, that does any sort of security monitoring will recognize and respect the fact that some countries have more blind spots than others. The ransomware attack for JBS, I think I went through that in the slide, but they had a significant number of operations down. So on May 30th, they announced that they had a significant number of operations down. Dragos did look at, I have some notes on this here, actually. That's a very good question, Mohammed. More than a dozen JBS facilities around the world and reviewed a large amount of telemetry related to this. The objective was to find signs of C2 and adversary-initiated exfiltration in their attack on JBS. Dragos did not find C2 in the analysis they conducted, but we did observe what appeared to be the exfiltration of gigabytes of data to the popular file storage service Mega from the network associated with JBS SA office in Brisbane. The exfiltration tactic Dragos observed was consistent with multiple previous reports of multiple ransomware operators using open source transfer tool rclone in combination with Mega to stage the stolen data. Of note, the exfiltration internet telemetry that we observed appeared to be test connections to Mega on 4 and 5 March, then a large upload on 7 March. Next batch of multiple gigabytes took place on 9 April. The final batch was uploaded on 30 May, the same day that JBS reported the attack. So this is actually a really, really good example. And I appreciate the question, Mohammed. This is a great example of how there's a huge delta between when the exfiltration or whatever the pre-steps to the ransomware attack are going to be actually begins and when it's actually discovered on the network. So, and this was almost two full months. Dragos enumerated the current upload infrastructure involved with Mega account holder uploads and storage across the world. Obviously, when you're observing uploading or you're observing internet telemetry, there can be blind spots in internet telemetry too. There's nothing perfect about that. So really, it's just it's a good technique because you can potentially allow disruption of the next phase or the last phase, the encryption phase. Lucas asks, how do you actually assign numbers to the actions taken in this category to generate a sum? Okay, so this is something that would need more work, right? And again, I think this would be up to the organization to assign the number. How confident do you feel between, if I said to you between 0 and 1, how confident do you feel that your firewall is actually stopping what the firewall is supposed to stop? And most people would probably say, well, I'm pretty confident. So you might give it a 0.75. You might give it a 0.8, something like that. Yeah, I mean, so there's no specific way to assign those numbers at this time. That's an area that where I would intend to do some more research. So Mike asked, how does this relate to the FAIR methodology or risk analysis qualification? It's a little different. I didn't really focus on that for this paper particularly, so I'll just state that it's different in that the underpinnings of what I'm using here are a little different. Would you share an example of how this has been applied in a real business scenario? David Williams states, this is brand new. I'm just talking to you all about this today. I do not have any good examples except for the 2 that I provided. In the white paper itself, I provide actually 4 or 5 different scenarios. So I don't have a good example of where this has been applied in real business. That's a great question though. Philip says, would the security of IT and security of OT factors consider maturity in all framework categories? That's a really good question too, Philip. Actually, I think that would be great to consider the maturity in this, and maybe that's some sort of either dampening or improving factor on the overall equation. But again, this is all new. So let's see. David also says, do the AU and AC components sufficient? Would you measure them distinctly for IT? Yes, and again, technically speaking, the way I design this sort of function and what it's based upon, you could actually create more than just the 4 functions I use in my example here. You could have 6, 7, 8, 9, 10, whatever you want for a number of functions. Is it fair to say that these are remediations of IT/OT? If so, how would one factor in the threat side of the equation mathematically? Okay, so yes, managing risk requires managing threat. Managing threats is very different, right? It's probably, yes, I'm assuming that the threat is effectively constant. That is correct. So that's a really good one, Ben. I like when I see these kind of questions. Yes, I'm assuming that the threat is always pegged at 1. It's always happening, full on threat. But probably assessing threat worldwide would be more of a stochastic determination, because there are multiple things, both criminal and geopolitical, that are interacting with the system constantly. So it's hard to say what one day is going to look like versus another. The only thing I can state very, very clearly is that it seems like ransomware actors like to attack things on Friday evenings or late Friday night, at least late Friday night or Friday evening, US East Coast time, which I always thought was rather interesting. So, and that could be due to a number of factors. Maybe people know that the United States is going on their weekend at that time, or maybe that's just convenient for them based on the attacker's time zone and location. Do I feel that air gapping might reduce the ransomware attacks? I'm very wary about air gapping. There's just too much research, and really a lot of research in the last 10 years or so on how to actually breach the air gap without even touching it. So I'm going to say no on that one. Are there any case studies of this formula being applied to a mock organization? The only case studies I have, Lucas, are the ones I put in my paper. Again, I don't have any data from the wild, so to speak. How zero trust Ricardo might provide help reduce chance. Wait, Nasser's question moving away. Yes, how can zero trust Ricardo improve or reduce the chance of ransomware infection, or at least help to improve detection? Well, again, that would be one of the values in the equation if you're doing some sort of zero trust schema. So yeah, I mean, it's going to help. Obviously, it would put you at a 0.99 or even a 1. Josh says, what types of difficulties do companies encounter implementing? I'm sorry, Josh, I don't have any evidence of any company implementing it again, this is research I conducted just 6 months ago. So I'd love to have this webinar in a year or two after some companies attempted to implement it and find out what worked and what didn't. Because obviously practical use is really the most important thing here. And I'm always up for hearing about how things work practically. It's those are the best teaching sort of situations for me as a researcher. Could it inform investment? I'm sorry, I can't speak to investment, but yes, it probably could. Yeah, but that might be a different set of equations, right? And we're talking about financial investment here. I'm assuming creating an operational budget or something. Yes, I think it could definitely inform investment. It would be helpful to inform investment too, because you would present this to your leadership as, hey, here's what we see. Here are the weak areas. Here are the strong areas. Here's a quantifiable sort of metric. It may not be perfect. The metric may not be perfect. In fact, I would argue that the metric is probably far from perfect, but it's something that shows in a very, very easy to understand way what needs to be done to shore up security in a given environment. So yeah, I think that'd be great. Let me see. If you get 0.75 and 0.25, yep. Okay. Let's see. Just want to see. The question, Megan, is do we get a link to the paper, the white paper?
Yeah, we will send a link to the white paper by the end of the week as well.
Okay, thank you very much, Megan. Okay, so I already answered. I've actually answered this one. Lucas's question about assigning numbers. Mike's question: would an assessment against a set of 800-53? Yep. Use a fixed set of values represents a level. I think, yeah, absolutely. No, there's no question about the value of 800-53/82. No question at all. And you know, 800-53 defense in depth and 800-82 being sort of the secure your OT environment. Yeah, those are great places to start. And see, this is what I'm talking about. This is great, Mike. This is where you're taking a policy that somebody wrote that's accepted pretty much worldwide, for better or for worse. It's accepted worldwide, and you can sit down and you can actually set up measures based on that. That is perfect. Sort of here's the qualified risk. Here's how we quantify it. I love that. Does the NIST cybersecurity framework have any utility, perhaps with supplements to an OT? Yes, actually it was posted before. 800-82, I believe, is and there's actually been some revisions to that. So yes, NIST framework has a very similar, as they do for defense in depth, they do have a very similar OT, secure OT environment type document. So the policies are out there. And again, I think it's a great idea to use a promulgated policy, you know, worldwide accepted policy, as a way to sort of qualify what you need to quantify in your organization. So it's good for planning, it's good for running the equation, it's good for everything, actually. So absolutely. Okay, it looks like did I get everybody's question? I would say, I don't want to say what's best. I would say both are always good. Ahmed says, we're running main control SCADA center or GCC member state main control center. What are the best scenarios to implement an assessment on the interface? Well, it certainly depends on a number of things, and I can't answer that question specifically, Ahmed, because I don't know what your topologies are looking like. But obviously, you want the SCADA, the control enclaves in your SCADA software to be separate from your enterprise IT. And if you're using any piece of enterprise IT to access that, you want to make sure that enterprise IT has, at a minimum, multi-factor authentication set up on it. Is it perfect? No, it's definitely not perfect. But obviously, we're always trying to get the number closest to 1, but we may never get it to 1. So. Stain says, yeah, I mean, yeah, again, this is just an idea I had. It's not perfect. It's not the only way to do it. You can do, I mean, you can certainly conduct your own research on that and do something similar or something better. Perfectly would love to read that, actually. Okay, Alfred says, with the increasing level of ransomware sophistication, what is your take about ransomware affecting actual PLCs? Well, again, there has been ransomware that has infiltrated OT infrastructure. The Ekans was one example of that last year and the year before. So I think it's possible. Have I witnessed it or experienced it? I have not seen it actually affecting a PLC, but the problem is if it affects, one of the units to which all the PLCs are connected, a master terminal unit, then it's probably going to be something we would have to be very, very wary of, certainly. Schwookant wants to know where can we find the latest cases of ransomware and OT security. Well, Dragos publishes a lot about ransomware and OT, but there's also a whole bunch of organizations that they're tracking ransomware on a regular basis. So I think really the sky is the limit with that. I think it depends on what sector you're looking at. Industrial control sector, Dragos definitely is developing more and more production in that area. So we will be tracking that, certainly. Okay, and I've answered Stain's question as well.
Okay, well, thank you for joining us today, and we'll send the recording out after the webinar along with Dr. Tom's white paper. Have a great day.
Thank you all very much.